Let us discuss in this video inverse functions. So what is an inverse function? So if we are given a function f of x, some functions are reversible, but not all of them. Okay, but what does it mean, reversible? So basically, you have your input x, you have your function f that takes it to an output f of x, and what we want to do is to do the inverse process. We want to go back. If you give me an y here, I need to find f minus y of y. Okay, so basically takes an output and brings it back to the input. Brings it back to the original input. Okay. So here's the thing. This is what we need to do. We need to send x to f of x, right? This is f acting. And then the inverse is going to take f of x back to x. So let's do some examples. The first example, let's start with something easier. Let's do a linear function. F of x equals x plus 3. Okay, and here we want to find the inverse. So what is the inverse? Did you notice here I wrote a different variable? I wrote y because the inverse is taking outputs for the original function and bringing the original inputs. Okay, so here what we need to do is say, okay, y, which is equal to f of x. This is x plus 3. So then we can solve for x, and this is y minus 3, correct? And this is going to be, you see that here on the right, I have a function of y. So here then I will say f minus 1 of y, the inverse of f is y minus 3. And this is the solution to the example, to the problem. But here we need to check, okay? So let me check that actually this is the inverse. The way I'm going to check, you can use either of these properties. You can do the inverse of f of x, then you have to recover x, or you can do the function of the inverse of y, and then you have to recover y. Either way is good. You see, basically you are saying that you are doing and undoing. So you should, if you do something then undo, you should get the original. Okay, so let's do the first one. F minus 1 of f of x. So this is, by the definition here in a star, okay, this is going to be f of x minus 3. And then f of x is x plus 3 minus 3, that gives x. So we are good. Please pause the video and you check the second condition. F of f minus 1 of y equal y. Now, one thing. Sometimes we just write f minus 1 of x, okay? Instead of f minus 1 of y. This is because sometimes doesn't really matter much. The name of the variable you use to describe the function is going to be the same rule, okay? So you will see this written also. Okay, so in this case, there is an inverse. So let's see now another example. Let's say now we take, very easy, a parabola, x squared. And then I ask, so if f of x equals 9, what is x? And you may be wondering, okay, x must be 3. So that's the inverse. But wait, careful here, because there is another possibility, which is x equals -3. Okay, either of these is going to work. So in this case, we have y equals x squared, right? When we try to solve for x, as we did before, there are two options. It's plus or minus the square root of y. Okay, so we need to choose one. Otherwise, remember the vertical line test. So otherwise, this is not defining a function. It's not going to be an inverse function, because for it, you see here, for 9, I have two options. For every x, I have the plus and the minus square root of y. So I'm getting, for each of the y's, I'm getting two possible x's. So that's not a function. Okay, so in this case, we don't have an inverse, unless we choose only one of the two roots. And then let's do one more example. F of x equals the sine of x. Okay, this one is typical, right? So if we have y equals to the sine of x, can I find an inverse? So let's do one particular example. Let's say f of x equals 1/2. So in this case, what is x? What is the original input? So I could go to the trigonometric circle. Okay, and then the sine equal to 1/2 is going to be this height over here. So that's going to give me this angle. Okay, and this angle is 30 degrees. 30 degrees is pi over 6. In this course, we are going to use mainly radians. Okay, so the angles will be always expressed in radians. But you could argue, if I look at this angle over here, sorry, this distance over here, that's also 1/2, and that corresponds to this angle, right? And what is that angle? That angle is 5 pi over 6. Okay, but you could be in the mood for argument, and you could say, well, why did you stop there? You could you might as well just go around one full turn, and you would still get the same sign. You will get pi over 6 plus 2 pi. And you can keep going. You can turn and turn. What we find here is that actually there are so many possible inputs that give the output 1/2. There is the pi over 6 that we found, plus any number of full turns. Okay, you can go forward or backwards. So this is, well, let me write. So this is 0 plus minus 1 plus minus 2 and so on. Or you could also take 5 pi over 6 plus 2k over pi. Okay, so you have infinitely many possibilities. Very good. So in this case, there is not an inverse unless we restrict ourselves to a smaller range of angles. Okay. Just to summarize. So if I want to, in order to recover inputs, f of x needs to be what is called one-to-one. Okay. This means it must take different inputs to different outputs. Different inputs to different outputs. Okay, so let's say I have, well, this is not, this is just to understand. Let's say I have the numbers 1, 2, 3, and then I want to send them to three letters, A, B, and C. Okay, so I could do like this. This is a function. Okay, but I could also decide, okay, well, let me copy this. So let's say now I send 2 and 3 to C. Is this a function? No, because two outputs are going to the same, two inputs are going to the same output. So if I try to go back from C, then I don't know if it's the output C is coming from the input 2 or the input 3. You see what I mean? So this is the same problem we're having with x squared and the sine of x, only those were a larger number of values.